Hi, I'm Charlie with Precision Matthews, and I am not handsome or charismatic enough to make my living on camera. That's why, in addition to these videos, I also provide tech support for our machines. In that capacity, I hear a few of the same questions repeated frequently. We have a 728 set up and ready to go, so we're going to make a quick video to go over some of those answers to the questions and maybe save you the phone call. Let's get started. We took the table off this 728 to show you exactly what hand wheel backlash is and how it's adjusted. For this demonstration, with an indicator against the end of the lead screw, we just move it back and forth to measure that play. I start out with about 5 thou of indicated backlash, tighten the bolt to clamp down on the lead screw, and then you can see it's down closer to 3 thou. What's happening here is that the screw we're adjusting squeezes that split nut, clamping just a little more on the thread to the lead screw. So why don't we simply clamp it all the way down to get 0 backlash? Well, if you did that, you'd have excessive drag on the hand wheel, and you'd wear out that brass lead screw nut quite quickly. We find that about 3 to 5 thou is the sweet spot. If you find that you have maybe 50 thou of backlash or more, and adjusting the split nut does not seem to have an effect on that, it's possible that one or both of these mounting screws have worked themselves loose, and the lead screw nut is no longer firmly secured to the casting. In that case, the nut itself moving back and forth as you change direction is causing what looks like backlash. To fix that, you just need to tighten the loose screw and maybe add a dab of blue Loctite to keep it from vibrating loose again. Of course, you don't need to take the table off. You can just move the hand wheel back and forth like this, not moving the table, but watching the hand wheel dial and feeling as the lead screw moves from one edge of the thread to the other. As you're turning the hand wheel, you can reach the screw on the other side to make your adjustments. We took the hand wheel and flange off so you can see, but depending on how flexible your wrists are and what tools you have, you may be able to reach this screw without disassembly. Another common question relates to a collet not going all the way into the spindle. There are 2 things that could be causing this, and each is easily remedied. The first possibility is that the collet set screw is screwed too far in. You can adjust that by lowering the quill to reveal this access hole, rotating the spindle to line up the set screw, and then simply backing it out until the set screw is short enough to go into the keyway in the collet. Brief sidebar here to talk about international standards and how they relate to collets. If you will open your Holy Bible, or Machinery's Handbook 31st edition, to page 1034, you'll see that the depth of that keyway should be 3/32 of an inch. In the real world, you'll find that collets aren't always so standard, and that keyway is sometimes shallower than that. There is another dimension that can give us problems, and that's found over here. Most collets are on the high side of this dimension, but if you feel up in the spindle, you'll find that there's a ridge that the collet needs to slide past that is just slightly larger than that. If that ridge has dirt or a burr or other imperfections from the factory, that can keep the collet from getting past that ridge. If you're getting hung up there, you just need to remove whatever imperfection there is from that ridge. Engine machine shops or well-equipped mechanic shops will probably have a bore hone that could do this job, but I'm not that advanced, so I don't have one of those. But the MacGyver in me knows how to tape a piece of sandpaper to a stick, and that's all you need. You just insert that from the bottom, contact that ridge, and then turn the spindle on for a few seconds at low speed to remove whatever burr or material is stopping the collet from going all the way in. You are above the taper, so you're not doing anything that's going to affect precision, so don't worry about that. We're just getting a little clearance for that top of the collet. The third subject that's a common question is how to adjust the tapered gibs on all 3 axes. You can think of the gib as a shallow wedge that can be pushed one way or the other to increase or decrease the pressure it's exerting to spread one dovetail surface from the other. This shallow taper is a bit hard to see on camera, but many shops have a similar wedge at a steeper angle, a doorstop. If you imagine my 2 hands are the 2 gib screws, you have a full understanding of how that tapered gib works. You can push one way or the other to add or subtract tension on each axis until you find a feel that you like. I hope that answers a few of the questions that you might have had about the 728. Now that this video exists, I guess I'll never get a call about lead screw backlash, collet fitment, or gib adjustment ever again. I'll have to figure out what to do with all my newfound free time. Maybe I can dedicate more time to my acting career. I am pretty handsome and charismatic. Anyway, leave us a comment if you think we missed anything, and don't forget to subscribe to the channel for more videos about common machining questions. Thanks for watching.